This wouldn't be an aerospace type of presentation if we didn't have an acronym. You will know and you will learn and you'll find that you have acronyms for everything. So the acronym for our presentation this morning is TFOAMARTRO and IoT. So when they ask you which presentation did you like the best, it's the TFOMA ROAR IoT presentation. So why are we here? Why are we here looking at this and why are we talking about this possibility of hacking the future? Easy. 2015, 24% of the hourly manufacturing employees and 18% of aerospace engineers were eligible for retirement. Boeing engineers, technicians and engineers, skilled labor, engineering, union folks, non-union folks, technicians age 50 and up, raise your hand if you're 50 and up, are going to retire. What does that mean to you guys who are not 50 and up? Really old people in aerospace are getting ready to retire soon. So there's a skills gap and there's a gap of information that's out there. What else does that mean? Not so old, but still old people are thinking about retiring and they'll be doing it in the next 5 to 10 years as well. So yeah, someone has had to come up with a solution to get us through that and get to the point where we're getting beyond what's happening today. And what does happen today is the usual knowledge transfer of someone sitting at a table, at a bench, at a drawing board, at a whiteboard, and they exchange paper documents, notes, Excel spreadsheets, PDFs, and say, here's how I do what I do. And you're like, great, Gramps, now what do I do? And so how do we transfer that information in that way to a form that's usable for you guys? Well, to understand why and how the engineer is passionate about what he does and why he has all this paper, we need to jump in the Wayback Machine. Wayback Machine, jump the slide early, so I'll use that for mine. So how did I get started in manufacturing? Well, I had a hard time finding a good shot of VHS duplication, half-inch videotape. We used to record those by hand in real time. So when you're watching The Lion King as kids, and just, I don't know, that's still just the next couple of steps for you guys. I watched that movie 97 times, recording it 20,000 VCRs at a time, making the 3.1 million VHS tapes that came out of that movie. Oh. Yeah, that's old school. And how did we schedule that stuff? All the 96-minute movies together, work together, and everything else. So, same facility at Technicolor, we started moving our way into digital media, CD manufacturing, 3 seconds a disc. Pop it in, boom, injection molding kicks it out, we're ready to go. Very easy manufacturing from that perspective. But how do you measure your scrap and non-conformance, which is a big thing in aerospace? You weigh how many discs aren't good. Whether the printing didn't come out good, whether the disc is warped, whether there's birefringence on there. Those little pits on the disc are anywhere from 3 to 7 microns long, 3 to 11 microns long, and about anywhere from 1.5 microns to 6 microns in the pitch end. So we can talk about CD manufacturing if you want, but they don't do that anymore as much as they used to. From there, I moved on to making tanks, which is kind of fun. Thermal control system, making the actual gunning system that would out there and control that information from the perspective. From there, I moved on to sensor systems within the application. So this is a little bit bigger UAV than most people are used to, but I did the radar system in Perez at Raytheon. Moved on to helping the folks that are out there setting up the planetarium. These are cameras for NASA and persistent surveillance, proprietary customers, as well as the James West Space Station. So I worked with a lot of PhD, a lot of very intelligent folks who could make amazing technologies, a microbillion ectoplasty for making the little camera detector on which kind of wavelength the light is capturing. Very brilliant guys, but ask them to buy something from the catalog and they are lost. So they need people that go in between those skill sets to help them get through. So now, how did I get involved, and why did I start thinking about the IoT and connected information? Well, back in the Stryker vehicle stage, in the main vehicle, in the early 2000s, they came up with this idea and this program called Future Combat Systems. How do I connect the battlefield? How do I connect the soldier to the drone, to the UAV, to the satellite information, and get them information real time? Super exciting, super great technology. You can see fiscal year 2000, 2006, I think, and 2010. So how do you connect the information? Everybody was carrying big stuff. Mobile GPSs were just coming out. All the technology that was out there from DARPA was just making its way to the battlefield. And manufacturing is moving from that point forward. But to understand where we're going, now we can jump in the Wayback Machine and find out what's going on. This is manufacturing in 1940s. This is a little bit of legacy left over from Frederick W. Taylor, the science and management. This is a guy in the early 1900s who talked about the science of the shop floor, how to make things more efficient, how to generate work instructions for the employee to follow, because there were a lot more people coming over into the country, a lot more skilled craftsmen, but not so much skilled in the abilities to making aircraft. This is when we had Rosie Revere, the engineer, Rosie, and all the people who are helping to make aerospace and make folks successful. Again, another small production line. Basically, things were assembled to a certain point and then moved down the production line to the next assembly area and then to follow on and follow on. So how can we kind of maybe think of our technology and the solutions today to get us more advanced in that manufacturing? So that's 1940s. Let's go on to the era of Top Gun and the 1980s. Where does that take us? F-14 Tomcat manufacturing. This is at the Grumman plant. Same thing. I actually purposely looked for a black and white photo, but it is 1980s. We're in the same idea. We got a factory line, we got stations, we got people walking up and down, dragging parts across, inspectors coming out. Not much different. So let's go to today, to recent history, next couple of years. KC Supertanker, for an example. Color photos, about the only difference. We have stations, we have planes, and they move through stations over and over again. The difference is, how do we deliver the information to that work center for the employee to use? How do we deliver the technical specs, the parts, the information that they need to do that information? How do we deliver the wire harnesses and the cables and everything that go inside to make sure that they're going to run them through the entire fuselage, and when they get to the very end, are they going to be short, or are they going to be long or too long to fit into the connector and made up properly? And then the ecosystem around it. We talk about the ecosystem. One aircraft is now made just by one manufacturer. You know, we see here Boeing in green, Lockheed in yellow, another Lockheed plant in Fort Worth in red, and then Pratt & Whitney for the engines. So how do we connect all of their data together in the digital thread, if you will, to bring that information and data into one plant so that when they go to fly the airplane, the pilot takes off, it's actually going to work. There are stories that when they first started doing this information, this type of parsing out of the building, that in Northrop Grumman in California, that they put the aircraft together and it was 3 feet too long beyond the spec. And they found out that they didn't allow for stack-ups and tolerances when the drawings that they submitted to everybody else to do their work. So how do you end up with a jet that's 3 feet too long? Oops. So we get to that point where augmented reality and artificial intelligence, how can that help us? Internet of Things. How am I connecting my sprinkler system to my doorbell, to my cell phone? People are thinking, oh great, now I can just ask the device, hey, can you turn on the lights for me? Can you turn on the fireplace for me? My room's too cold. Great idea. But then we have someone who's maybe a habitual optimizer and says, what about the shop floor? We can do that there too, right? And the idea is absolutely yes. Yes, we can. We can go ahead and bring this information, bring the sensors, bring the data, and start pumping out big data like left and right. And then all of a sudden someone said, whoa, this is a little harder than we thought. There's a lot more data. There's data security that's involved with getting that information up into the system. So we have to slow down. We definitely have to slow down because people in the industry have recalibrated their idea. So they figure, let's take a closer look. Let's go ahead and walk this back. We do some use cases. We're going to do some kind of after the analysis, or post-mortem as they call them sometimes in the defense industry. What did we do? What went wrong? How can we fix it for the next time? Lessons learned. And this might be something you can use in your design today as you guys go through your process. What did I learn? What is working? What isn't working? What do I have to change in the scope of my project? Because it is the project that we're working on this weekend. Well, they're going like, well, we have some technology out there, barcode scanner. It's working pretty well. But how do we build on that? So, what do we build on? Again, people want to name things. What is it? How are we going to surround ourselves around it? So, okay, what should we call it? We have a survey. Industry partners like Gartner, SCORE, Mesa. These are organizations that live around the manufacturing process and how they do what they do and how employees and everybody else does what they do. ISA 95, the factory standard for machine-to-machine language communication. Well, they decided on smart factory. Smartphone, smart factory makes sense. There was a big survey. Other names came in second, third, and fourth, but we decided that smart factory was it. Next on the survey, they asked, where do you see the most value in your smart or connected factory? Well, if you can't see, I can see it very well from here, but connected supply chain and the value chain, the data that goes along with the information that you're building. Next is manufacturing execution, robotics, sustainable production, predictive and prescriptive analytics, which we saw in our presentation regarding the test equipment that's out there, smart machines, smart connected factory, big data analytics and the data lakes, and then cloud computing. All topics that we've talked about today, but from a manufacturing perspective, this is how they see it in their industry, in their vertical, if you will. So, the industrial Internet of Things, smart is surrounded around our smart factory idea. What's next? Well, the next idea on this is the digital thread. How do we connect our engineering data, our product lifecycle management? Once you have your UAV and your software, how do we get it from new product introduction to design to prototype and out in the field? And then how do we continue to maintain that, the cycle of improvements and all the corrections that happen in that process, and getting it back through that loop. And again, manufacturing operations management, or MES solutions as well. How do we manage what we do on a day-to-day basis and accomplish and then bring that information together? Then there's the value chain, our resources, our operations, and compliance. You know, when you're building things for customers, especially government customers, there's a sense of regulations that need to be complete and part of that process. Did I follow my compliant materials? Did I source from percentage of minority-owned, women-owned, you know, Native American businesses? These are all compliance things that are part of that process that maybe you don't think of, but we have those smart technicians and engineers in the entire ecosystem within your organization that help us do this. So now that we've got the idea that we're going to slow down a little bit, we're going to focus on connecting that value chain, the supply chain, and that information. We're going to add, you know, just enough sensors. This is a kind of a wafer, semiconductor wafer inspection area. Again, the same thing with circuit boards. How can we smartly build and give our data out? You know, when we have a circuit board here, we have our connections. There's within the circuit board, there's things called vias, connecting the multiple layers of the board to help guide the signal within that board. It's not just on the top, it's within the board and then the connectors. And then we have machines called plug-and-place machines that actually grab these parts on long reels. You buy them a couple thousand at a time. And with the programming of that machine, with the data that comes from engineering through the digital file, as opposed to the technician manually punching that, we now were to put and place those machines basically within the system, so that we can slowly and quickly make our way to the more advanced robotics. Again, there's still a lot of hands-on technician work that happens in the aerospace, but there is still also room for adding this, this type of machinery and the data coming back to it. And how to control that big data and make sure that it's safe and accessible, and it tells a story to the folks that are out there. So one of the ways that are particularly appealing to me, and I hope it's particularly appealing to you, is how we talk about manufacturing and how that's going to move on within the system. And we're getting to the augmented reality part of this, I promise. We just want to set up the base. Typically, and in most factories today, they are using paper instructions. Paper instructions where the technician looks at what they have. Sometimes there's a drawing on it. Sometimes it's just a spreadsheet where they check off, sign, and do what they need to do. How repeatable do you think that is on a day-to-day basis? How accurate do you think it is that someone remembers to do everything that they're supposed to do, or it's 4 o'clock, they're waiting on their way out of there, they've got to get to the game, they've got to get to the kids' events, how do they get to where they go and still maintain that they're doing this right? Sometimes it slips. So what can we do to help them out? Well, we're going to make our electronic work instructions. Electronic work instructions, and not Excel, but actual electronic work instructions are going to help keep them in line and follow the process. We're going to be able to connect directly to engineering drawings, the CADs, the E-data systems, the SolidWorks drawings, if you will, and embed them into those drawings so that the technicians can do what they need to do. And we're going to eliminate the paper. It's only good for the environment. It's good for the shop floor. Hey, did you see that folder on that particular part? No, I haven't seen it. I left it on so-and-so's desk. The lab, you guys got to work in labs. Was there a lab book? Who writing in the lab book? Who made the last notation? And then we're going to improve quality in the first pass. And that's a lot of things for a lot of folks. It's a financial initiative. If I have to go back and correct something, excuse me here, if I have to correct something, the further it is in the process, the more expensive it is to fix by a factor of 10. If I find a design issue in my drawing, my inside right angles are wrong, or I can't actually assemble the thing, but I fix my drawing, very inexpensive. Engineer's time is expensive, but not as expensive as buying parts, getting out on the floor, getting it reworked to the machine shop, and then coming back out. Last thing you don't want to avoid is getting it out to your customer. Your customer sees that information, they have the part, it doesn't work for them, your reputation takes a hit. You know, with 1 or 2 bad deliveries like that, it takes a long time to get your stuff back out there and in their face so that they're actually trusting you to do that. So what would those look like? This is courtesy of some friends of mine at iBase Tea. Slumina is the product that they talk about. And this is a very interesting example of a MES, or manufacturing execution solution. By no means do you need to go as detailed as this. You can get even more detail if you like, but this is some rich text, not super high tech yet. Rich text information telling the technician where to look on that nose cone, what part are they using, can they verify the quantity of the part, maybe the serial number here, and did they actually use that part, did they replace the part, did they verify the alignment as the call out says. Now it's easy for the technician to sign on, hit next, document what they did, because the system's going to collect that data, close it out, and move on. We now know that the technician actually completed that. There's security sign-offs for that employee on that laptop, or that information or that workstation. We know that their certifications are valid because to log in and to do those operations, certifications have to be in place. And we know that that data being connected to the ERP system, or Enterprise Resource Planning System, is now pushing that up in real time, about 10 to 15 minute intervals, to the production people, to the schedulers, to everybody else who's interested in the data, and no longer is the technician focused on, yes, I passed that part on, no, I moved it over the shipping dock, yes, it's in inventory. Now the information's out there. Now it's a matter of being a customer of the data and making sure that they're able to access that. So when you talk to your friends, when you talk to your parents, your family, you're at a reunion, and say, hey, I'm super into this AR, VR stuff. Oh, that's great. Well, you know, then you ask them, so what does that mean to you? Well, most people today, if you ask, and maybe if we go down to the casino, we can ask them as well, they think of something like this. Can I analyze my golf stroke? Is it really going to show me how far it's going to go? This is what they think of this technology is going to bring to them. And absolutely not. We need to go and think beyond this. We need to be able to get out of this manual knowledge transfer and get to the point where we're actually digitally transferring those skill sets, work instructions, the training, if you will. What happens if we're at that SCADA machine and the guy's on the field remotely and he doesn't know what he needs to do? He's got to drive 40 miles back to ask a question, get on his radio. Maybe if they're connected now, they're in VR, they can see each other's information, interact, fix the problem there, and now we've avoided a lot of issues. So, something else to think about here. And these are hard to find uncleared images when you don't create your own content. I will say that so. So this is kind of a service and maintenance thing, and we can tell that this is a kind of a fun diagram that you're using here. So they're using this camera, this laptop, if you will, to kind of show what needs to happen. This is bad, this is bad, this is good. Very simple green and red on the information. But there's one thing that tells us that this is not, this is kind of a mock-up for this, and I'm not going to go too harsh on them. You wouldn't use anything without any kind of ruggedized case. People who schedule people who schedule the shop floors, people who schedule manufacturing are control enthusiasts, is a nice way of saying control freak. So they're very organized and they're control enthusiasts. And when they look at it, say, you know, I've got a work center, I've got people, I've got resources, how much can I push through that in any one day? Well, they look at information from the stock, they look at who's signed in for the information that day, who's in the employee, what their skill set is. What if we could automate and compile that data for that scheduler to say, you've got 14 people in, 3 of them have this skill, 9 have this skill, 8 have this skill. I don't know if that's 14 or not, but we'll go with that. We have these parts in place. Traffic was really bad today on the freeway. 4 of them are going to be late because they live here. 6 are going to be on time and 1's going to be early. How would you do that? The idea of the minority report again, this is again one of those clear images that allows safe to use. Had I known he was going to be here in advance more and paid attention, I would have asked him for one of his images. But what if the scheduler could then grab all that data, have that transferred to them, and then physically manipulate what's going to happen that day in the facility, or for the next 2 or 3 weeks? Or someone walks in and says, hey, what if, because the product guys always do this, what if we ship this in early? What's it going to push out? Hang on a second. We're good. We're good. This order's going to be late 2 days. This is going to be fine. This one's going to be okay. We'll call the customer and take care of that. Right now, that's typically in a regular shop floor, about a day and a half exercise in tribal knowledge, Excel spreadsheets, computing, maybe TM1 if they're a little more advanced, a little data analytics and data cube. These are real world issues that people solve. How do I get my Orion rocket? How do I get my jet out on time, in compliance, and under budget? You know, money's flying right now to the defense industry, fast and hard. Time to get in there and make sure that you can deliver and be part of that next wave of stuff that happened back in the 80s, that you are a successful contractor. Because we really want more than just this when we're looking at drone and UAV and artificial intelligence. This is fun, it's a great idea, but we really want to do more of this kind of stuff there. So I'm going to pause. Right, Ross, how are we doing on time? We're getting close to our 10 o'clock. 5 minutes. Perfect. I condensed my 45-minute presentation down to 30 minutes, which I usually talk a little fast.